Same thing you say every time. Gotta say it.
There we go. All right, well, my name is VanArsdale. I'm the manager of the Rapid Transfers and Tap to Local Services team.
I'm Matt Lowrance. I'm on Van's team. I'm a software engineer. I've been at Jack Henry for, it'll be 15 years in March, so enjoyed my time here. All right.
All right, well, Matt and I are here to present on Rapid Transfers, obviously. Rapid Transfers provides it's a new product that provides near instant, secure me-to-me money movement over MasterCard and Visa debit card networks. And near instant is actually not an exaggeration. In my personal experience using Rapid Transfers at my bank, I've never had a transfer take more than 5 seconds to complete. And the great thing for anyone here who's representing a bank or a credit union is that your customers get to use the same accounts and shares that they already have established. All they have to do is go in, they link a debit card, an external card to their account, and the card will go through a validation process with MasterCard or Visa, and they can immediately start using the card. They don't have to enter in micro deposit amounts, they don't have to wait 3 days, they can just start moving money around. Rapid Transfers was created with deep collaboration with Move, as you've heard earlier. And they're just a fantastic group of people to work with. I would say that even if they weren't sitting on the second row there. So Rapid Transfers, like I mentioned, leverages MasterCard Direct and Visa Send to rapidly move money. There's no ACH involved on the transfers themselves. There's ACH with the settlement process, but we'll get to that in a little bit. We built a lot of fraud prevention into Rapid Transfers. When the user initiates the card linking process, it triggers a high-risk authorization in our system that requires multi-factor authentication in order to continue. And when you start working with cards, of course, you're dealing with PCI data. And as we all know, that can be a difficult problem to solve in order to handle the data in a good way. So to that end, all the card information that's entered on the device by the user when they're linking their card is fully encrypted on the device using a token that you'll retrieve from our services. That encrypted payload is sent through to Move, and only they have the decryption key. The card networks, Visa and MasterCard both, will complete a card validation process that includes name verification, address verification, all to ensure that the card is valid and can be used by the person who's trying to use it. Move completes sanction screening on all the transfers. And we also have amount and velocity limits in place that are configurable by financial institution. In addition to those, there are also amount and velocity limits in place with Move and the card networks, just to ensure that there's no fraudulent activity happening. So all of that together just has created a very secure and risk-averse system. We are fully integrated with Silver Lake, CIF 2020, Core Director, and Scimitar. We're open, of course, to integrating with other core products as well. Our APIs are publicly available, and all the documentation is available on jackhenry.dev. Matt's going to take us through what that integration might look like for you here in just a little bit. There are two types of transfers, a push and a pull. Push transfer moves money out of your account into an external debit card account, and that incurs a 1.75% fee with a 50-cent minimum, and then there's the pull transfer, which is obviously the opposite direction, and it moves money out of that external account back into your primary account. And that incurs a 0.75% fee also with a 50-cent minimum. When we process the transactions, we handle all the core orchestration for you. So we take care of all of the, debiting or crediting the user's account, handling all the GL postings, processing all the fees. All you have to do is send us a payload that tells us how much you want to move and where you want to move it, and we take it from there. Every day at 3 o'clock, Move will settle all the accounts and initiate an ACH transfer with each financial institution. That's the only place that ACH is involved. If there are any issues or any problems with any of the transfers, we are, like Mac mentioned earlier, we're integrated with Jack Henry Exception Manager, so everything will appear there. And as a financial institution, that's where you would work through any of those issues. We are actively working with Jack Henry Insights to create some reports and dashboards. And all of our data is already in Data Hub, so you can actually just create your own custom reports or dashboards. And with that, Matt's going to take us through some code.
All right, good. We got this slide fixed just in time. Earlier it was going to be a technical discuss-ite, but we got that fixed, so I'm actually prepared for this discussion, which is good, because the other one I was not. So we have these are rapid transfer APIs. They kind of break down in 3 major sections. We're going to talk mostly about the 2. These are the consumer ones. There are admin APIs, and I will talk about those a little bit, but we'll come to that at the end. Payment methods is where you are able to link the card, as Van was talking about. We'll see that later. We walk through linking the card. We can add debit cards. We also can list our list of payment methods. So that's the cards that the user has registered, the accounts that they have access to, as we mentioned, and then you can delete cards and payment methods. So you can show them when they want to do their push or their pull, display what their options are to display that transfer. We've got our transfer endpoints. Those are the ones that actually pretty much handle moving the money. So you can create a transfer. You can list all the transfers. And we've got a review endpoint. So the review endpoint is nice. That shows you all that calculation, so you don't have to do it for you. Van mentioned there are fees. So we have an endpoint where once they pick their to and from, they enter their dollar amount. You post to the review endpoint. We do that calculation, show the fees. We do the limits calculation ahead of time. So it provides some additional information to the end user that, hey, you're already over your limit, or you can do one more today. Those sort of hints on the limits that you can see ahead of time, or prevent the transfer from happening at all if the limits are already over. And then go ahead and finish the transfer. The admin APIs, like I said, I'll cover a little bit more here in a minute. We have a couple of videos that are demos. I originally was going to do some live coding, but they encouraged us very hard not to do that. And actually what I was going to do was, I don't know how many of you are into agentic engineering at this point, but I work a lot with AI agents. So my plan was to just type a prompt and let it do the code while we were talking. That would have been a disaster, but it would have been fun to watch. So instead, I just recorded a video. They wanted us to record a video. I thought that, a video of an AI generating code seemed like it would be kind of boring, but that's what they told us to do. So here we go. Here's 10 minutes. I missed look, I set it up too fast. Messed up my own thing. Here's a couple of our APIs. There's cards and transfers. These are the particular ones we're going to look at, is linking the card and looking at the transfer. So I have 2 sections that we're going to talk through. There's a new authentication model that Jack Henry offers. It's a token exchange. It's very new. It was actually not written by our team, but it was something that I could learn. So for this presentation, I used it, and the demo goes over it so that you can kind of see a different way to authenticate. In the end, you need a consumer token. So it gets you the option to come through with a client creds and then change to a consumer token, and then make these calls with your fine-grained scopes that you get on a consumer token. We'll see that here in a second once the video actually starts and I don't skip too fast. And then we have link a card. That's the other one we'll talk through, which is kind of the PCI protection endpoint. So I think now we're going to see 10 minutes of Copilot generating code.
What I have here is a little sample application. This code is all out in the GitHub repo that we'll have links to at the end of the presentation. To start with, this is a little tech TUI. Most of this is agentic engineering, pretty much all generated code, especially all the UI parts of it. Did help a little bit with some of the auth, but 99% of this is all generated code. So let's go ahead and get started. What we're going to look at here is this token exchange process that I was discussing, or that we've seen a little bit about. Here's the consumer token, and then, you can see we're at a breakpoint where we're going to hit the actor token and then exchange that for the consumer token. We'll walk through this code a little bit and kind of watch it run. Let me start this up. So what we have here is just a little, like I said, terminal application. I might be able to make this a little bit bigger. So we have a few options. We can configure authentication. I've already taken care of that. We can authenticate. That's what we're going to look at now. And then there's several of the other rapid transfers APIs that are consumed. Again, this is all in that GitHub repo, so that's just examples for anybody to look at if they want to see this code. So let's go ahead and authenticate, and we're going to jump into this code. Let's see if I can close that. So as you can see, first we're going to actually get the actor token. And if you've done any OAuth, this is just client creds flow. I'm not going to spend a lot of time on that. We'll just step over it. But the important thing here is we can see that we did get a token. So there was our token response. There's that. We'll see this here in a minute, and we'll go back and look at it. You can see the scope, and we'll talk about that. So we're going to step forward. What's more interesting is here in this token exchange. So if we step into here, we can see that here we're going to create this subject token. The subject token is just a very simple token, just a little jot with just the user ID in it. That's plain text. And then here's where we're actually creating that token exchange request. So we've got the grant type, that's a special grant type. Again, this is all documented. There's the subject token that we just created, and then we set the token type. Again, all documented out in that repo for you to find. The actor token is the one that's the client creds token that we just retrieved. And same thing, token type, and then our scopes. We can see on this particular consumer token, we want the scopes that we need. We're getting, and we'll look at these, but here's the iRisk, high risk auth, and the payment, the rapid transfers related scopes. So we'll step through this, let it go ahead and create all of those, and I'm just gonna let it go forward from here. And if we come back over here, we'll see our tokens got sent out. So there's our consumer token, and our actor token is up there. There's a little bit of a helper here that it lets me copy these. So first let's hit the A button. That'll copy our actor token, and then I can change over to my browser where I have jot.io open, and we'll paste that in. And here we can see this is our first one. This is our enterprise token. It's just a service account that I created called the Rapid Transfers DevCon service account. And we can see that the only scope that I really cared about in this particular case is just that token exchange scope. So this client credentials flow token has the rights to run the token exchange. And then secondarily, if we copy the consumer token, now this is the token that we exchanged for. And now we see that I am actually a client auth type, so I'm a consumer token, and I have my consumer app ID in there. Here's my user ID and my user that I'm going to act against, and my scopes that I have. So now that we have an auth token, the app does a little bit of stuff and it stores it. But let's just go ahead and create a transfer because now we're authenticated. So we can say, okay, we're going to do a pull from card. We have a Visa card set up, and we have our couple of accounts that are assigned to my user. So I'm going to pick this one. I like to use the time of day that my transfer is happening as, because that's easier to go back and look or find it later. So it's 8:56 right now, so I'm going to make my transfer for $8.56. We see the review screen that says there's going to be a 50-cent fee, and I hit Y to confirm, and now it's going to go ahead and go create that transfer. We will see that it created the transfer, and now if we go back on the list endpoint, we can see it's a little hard to read, but there's my $8.56 fee, or $8.56 transfer that happened right here at 8:56 in the morning. Just as one more thing to see, we can come back over here to Bano Dev Bank and log in with my user, and we can hop over to transfers, rapid transfers, and there's my $8.56 transfer. So just we're working against the live environment. The little thing, the test app is actually running against all the real APIs, making the API calls. And also, just so we can see it, you can see here on the back end, here's my transfer, and here's my $9.60. So there's the 50-cent fee and the actual $9.06 that nets out to the $8.56 that we ran against the core. So here's the actual core orchestration that we've talked about as well. So that's the auth model, pretty simple to run through. You can exchange your token and get the consumer token that you need to make these calls.
All right, I'm not going to spend a lot of time on this token exchange because the video did, and you saw it, how it works. But it's just one of the ways. There's many auth models that you can use. Any of the consumer auth models, auth models that you have. Like I said, this one was interesting to me because I hadn't done it yet, so I got to learn something and put it in there. Here's a quick little I made a real big version of the sequence diagram. There's a much better sequence diagram in that GitHub repo that I'll have a link to at the end. This is about half of it that you can see. And then here's the other half. Finish it, and then once you get your consumer access token, you see there at the bottom, we finish our token, and now we can make our API calls. You saw in there we made 2 or 3 of the calls. and I just here in the moment realized that probably a better slide for us to have landed on here would have been our scopes. While I talk about those other APIs, would have been our scopes. But I assume we cannot make changes to the slides at this point. They're locked? Yes? I'm seeing yes. I can't change the slides. Okay. Well, pretend that these were our scopes. Our scopes are on jackhenry.dev, out in the consumer token. So if you want to see them, you did see them in there, but you can see them out on jackhenry.dev as well in our YAML file. So those 3 calls that we made, you saw we made list transfers. Once we had our token, we listed the transfers that this user had and that they have completed. That's a pretty simple one. We've all called a get endpoint. It's just a get endpoint that you called many times. We called review. Like I said, review is the interesting one there in between. Review gets you the calculations and the limits. So review lets you show the user, hey, I did an $8 one, but how much ever your transfer is, we calculated your fee. This is what the fee for this transfer is going to be. And also, and it didn't show in that demo, but it does also show you what their limits are and what their remaining, what values they have left for their remaining limits. It'll calculate limits for transfer amounts per day, transfer number per day, and those sorts of things, and then give back that information so that it's some sort of UI that you would build could display and let them know how many transfers they have allowed remaining for that particular day. So I think that's those 3 API calls. They are the kind of crux of rapid transfers. You can list transfers, create transfers, and do review. That's the steps to create a transfer. Oh, we also made payment methods. Whoops, I forgot. Because it's kind of hidden in there, we made the payment methods call. That's the one that lists out the available methods. So that's the cards that the user has registered, and then the accounts on whatever backend system, like Van talked about, that's currently the Jack Henry cores, but we are agnostic to the account source. So we can pull those from somewhere else and return those back to you as the same object model that you would get for any of the Jack Henry cores. That lets you show that drop down or those lists of here, I'm going to pick this card or I'm going to pick this account and swap back and forth for which direction that transfer is going to go. That endpoint was in there as well. So I think that's everything on the transfers. I think I'm ready to move on to link a card, and I've got another little video for link a card. Let me switch
A little bit here in the app. We're now in the web UI. Again, all of this code out in the GitHub repo, and you can see it all. The web UI is actually talking to the little Go app that we saw earlier. That's acting as the proxy for it. To avoid course problems, I am just proxying all the endpoints through the Go app, but it is using all the correct URL paths and things like that. We'll see that when we look at the code here in a second. Here's the transfers list. Let's go ahead and look at link a card. That's what we're looking at right now. There's a list of well-known cards that work in test mode. There's some links to those in the repo. You can have those. So let me paste that in. You can use any date in the future. So I'm just going to use 12/29 and 1/23. And we'll go ahead and hit link a card. And what we're going to see is link a card is a high-risk authorized endpoint. So I actually got challenged. If we hop over to the Chrome tools, we're going to see I called post cards and I got a 403. That's that high-risk authorization challenge. So let's look at the code for a second. So we can see here in do link card that there's the HRA password. If I pass that in and my step up auth implementation is very poor, it's just pass the password. If they match exactly, good enough, and it works. Obviously, there should be something better for step. You could do something better for step up auth. It was good enough for my case, but we'll see over here in the manager if we say include HRA, then we ask for that separate HRA scope. In the TUI, it's just always asking for that. It's hard coded. In the web app, it's actually passing through the process. So once we do that and we call back through, so it gets the 403, it passes it back with the password, it posts, then we step into the do link card. So we go get the encryption keys, and this is just calling that API endpoint for the end-to-end keys. It's a pretty simple call. It gets the encryption key. Then we continue down. We do a little parsing of the form data. We make sure that it's only a 2-digit year. We create the card details object. This is a little object that's going to become the JSON token. And then here we go, we'll go in and look at that card. So there's the encrypt data. And you can see this is mostly just using the encryption library. So we create that JSON payload, card number, CVV, expiration data, and then we encode it. And now we have our token. Oh, one more. And now we come back to the main request, we'll see that our request only has the first four of the card number, the first digit of the card number, and the encrypted token. We use that first digit to do a little bit of validation. Currently, this is only supported for Visa and MasterCard. So if we look and make sure that's not one of those, we go ahead and stop the request. No reason to let it continue forward. And then secondarily, we only set that encrypted token. So before the data ever leaves the device, it's encrypted on device. No sensitive data ever leaves the device. It is only an encrypted token that leaves there. So then we go ahead and call the post endpoint like we should, go forward, and we'll get that response back, and we'll have linked the card. So let's hop back over now again, and we will link a card. It's going to pop up again and challenge me for my password. I will type in my super secure password, definitely not just the word Jack Henry all lowercase. And with my correct password, it's going to come through and say the card was linked successfully. There's our new card ID, and we can look at the delete card. We're not going to delete cards, but we'll now see I have that Visa that we created earlier, or we used earlier, and I created earlier, and we used in the earlier, and then here's the MasterCard that I just created as 820. So this was just a process for doing that step up auth and also encrypting the link a card token.
All right, so we can go ahead and talk through link a card now. So link a card's a couple of steps. First, we get an encryption token. You saw that was that first call that we made. So we make that call out to that E2E endpoint, and that gives us our encryption token that we're then going to use to turn around and encrypt that token data, similar to what we saw Andrew talk about a little while ago. We get a token, we put that data in there. Sorry, we get an encryption key, we create a token, we encrypt that key, and then we send that to the API. That data never leaves the device unencrypted. It is encrypted from there forward, and nothing is ever passed. The only thing that are passed from then on are UUIDs, which are anonymous, basically. They don't have much value. So we get off there, get off the machine, get off the device with all encrypted data. We do return an API with a little bit of token, a little bit of card data. It gives you enough to understand your payment ID and things like that once you link a card. While that happens, that is when all of that data, so during that process, what you saw, all those checks that Van was talking about happened. We checked name and address, we checked validation of the person, and did all of our safety checks, all of our fraud checks while we were linking that card. That was all in process right there. We also, at the time, can automatically, if we haven't found this person yet, create any and all required accounts behind the scenes for them too. So if this is a new user, they link a card, they don't have to do any kind of sign up. We just grab all the data from our data source, store it, and create their account as well. So it all happens automatically in flow. They never know the difference. There's no sign up, no anything. They just put in their card, they're signed up, and they're ready to run a transfer. So here's another quick sequence diagram. Again, this is an exploded version, so you all could see it on the screen. In the repo, there's a much more detailed version that kind of goes through this, but the user inputs the card details. We get the encryption key. From there, we generate the keys and we encrypt the card. That data, as we see right there, happens in the application or on the device. We get that encrypted data. Not going to leave here. It's going to head off from the device, all encrypted in that token. Last step, we submit the encrypted card. That goes through. We decrypt those values, send that card metadata back, and they get back card linked. Again, actually not mentioned, but there's several other things that happen in the background with validation, account creation, and a lot of other orchestration besides core orchestration, but there's account orchestration and things that happen automatically, unbeknownst to the user and unbeknownst to you. All happens automatically. You just submit it. We take care of all of that in the background. So real quickly, I'm just going to run through the remainder of our APIs, just kind of what APIs exist. These are our consumer APIs. We've kind of talked about them, but just one at a time. It is a fairly small API surface for this application because we try our best to do as much of this for you as we can. We do all of the core orchestration in the background. We do all of the account orchestration, et cetera. You only have to call 3 or 4 endpoints: payment methods, transfers, and end-to-end encryptions. So again, payment methods, that tells you where all of your all transfer enabled cards. I thought there was a typo there, but there wasn't. It lets you see your cards that the person has registered. It lets you link new cards with high-risk authorization, and then there is the ability to delete or disable a card. If a user no longer wants to use a particular card, they can go in and remove it. Part of that process, during the link a card, we do all that account creation. Transfers, we saw both of those. Well, we didn't see create, push, and pull, but as discussed, we can go either way. We can pull from a card, we can push to a card. Both directions are available in the transfers endpoint. View transfer his status and history, that was the list endpoint we saw. You can see all the transfers for a particular user, the transfers that they have created in their history, and then review transfer details, including fees. We saw that endpoint. That's the review where it calculates all the fees for you and the information just before, as a review screen for the user, just before submitting the transfer. And end-to-end encryption is that last, generate the keys, or grab the encryption keys to generate the token to generate, to pass the card along. We have our admin APIs. I'm not going to spend a whole lot of time on them. They are mostly just about configuration. If you were going to build an entire integration system with rapid transfers, you would want to manage, you would want to look into these. This is how you'd configure things like core operations, GL transactions, all the stuff that no one wants to hear me talk about right now, but we do have to do those things for actually properly posting these transactions on the back end, so we have all of the endpoints available to set up the FI's configurations with their GL transaction codes, all those sorts of things. Statistics. We forgot to update statistics to this morning, so we're going to skip this slide, and we're going to be done. It's almost lunchtime, so we don't want to keep you all any longer. These are our resources. You don't need to rush to run through all those. This QR code will take you to that GitHub repo where all of that sample code is. There's the Go code and the HTML code. On that, as I mentioned, most of that code is done with agentic engineering. I don't know how many of you are messing with AI coding. I did review the Go code. It is not egregious. I don't think anyone will be offended by it. I have not done web coding in several years, so the HTML and JavaScript, I don't know, might be terrible. It at least worked well enough to do the demo. I think my total prompt for the web API was, or the web UI was, okay, now build a web UI and make it green. My favorite color is green. And it did a pretty good job. If you saw it, it did a decent job and it functioned. So that's what I like to put. So I think that's all we've got. Appreciate it. Thanks, everybody.